Hi, this video is about multi-area OSPF. The reason why we are using OSPF in a larger scale and in multi-areas is because we want to make sure that our routing tables will not be too large, because in that way our routing process will be ineffective. So we're trying to make it more effective by making the routing table smaller, and we can do that by segmenting our entire routing domain, and we do that by creating different areas. So that is why we are using multi-area. And we will look at how it works, and we will look at the different implementations about both OSPF version 2 for IP version 4 and OSPF version 3 for IP version 6. Yeah, so the whole idea is to create smaller areas and to make our routing tables smaller. Of course, there is these operations within the OSPF itself, that our link state database will also be huge if we have one large area. So instead we create smaller areas, and therefore our database will also get smaller. So overall, OSPF will be more efficient and more scalable if we are using different areas. Of course, also the SPF, the shortest path first algorithm, if we have a large area and there is a change, well, then the entire process needs to be rerun. If we have smaller areas, then it's only within one area that we have to recalculate the shortest path first algorithm. Yeah, so what we do is that we basically just create smaller areas instead of having one large. Typically we are using area 0, but now we have area 0 is actually a specific one. This is our backbone area. So all our other areas need to be connected to area 1. But then, for instance, here in this example, we have area 1 and we have, area 0 is the backbone. Area 1 is just a normal area. Area 51 is another one. So the number is irrelevant, but it's only area 0 that is specific. So the routing tables will then be smaller, because within area 1 we will see all the networks within that area. We will not see all the networks within area 51, but they can be reached by going through area 0. So area 0 is, as I said, our backbone network. So within, so the routing tables and the link state database and the link state updates will only be sent within an area. So we have what we call a two-layer hierarchy. The specific one, area 0, which connects all other areas, and then the normal areas. You can, when you choose to implement this, you can set it up, for example, through the geographical grouping, so that if you have a large company, one area will be on one location, another area will be on another location, and then you have your infrastructure backbone in area 0. So all traffic must go through area 0, which is the transit area. When we look at the different areas, the different routers will then have different roles. An internal router is within all the routers within the same, who has all its interfaces within the same area. A backbone router is a router in the backbone area, in area 0, and that it has all the interfaces in the backbone. An area border router is a router that has one interface attached to, its interfaces are attached to different areas. For instance, here, router 1 and router 2 are border areas because they are connected to different areas. And then we have an autonomous system boundary router is if there is a router that's also connected to the internet, for instance, which in this case here is router 1. A router can be classified as more than one type of router. For instance, we have router 1, which is both an ASBR and an ABR. Yeah, then we have these different link state announcements or advertisements, which is what OSPF is sending out to get connected to all the other OSPF routers. We have these different types. Actually, it's 11 types of LSAs, but we will only cover from 1 to 5 in this curriculum. And we can see that the type 1 LSA includes a list of directly connected networks and their prefix and link types. So all routers generate a type 1 LSA. Type 1 LSA are flooded within an area and do not propagate beyond the ABR. So this is the updates that's sent about the networks within the same area. A type 1 LSA link state ID is identified by the router ID of the originated router. So they are using, this is the normal one. This is the one that we are also using when we have single or area OSPF. Then we have the type 2 LSAs that are identified for the routers and the network addresses of the multi-access links. Only a DR if we have, because when we have multi-access links, that's typically when we have more routers connected to a fast Ethernet. And then we saw also when we talked about a single area OSPF, to avoid having all these flooding of LSAs, one of them are elected the DR, and we can have another one who is the BDR. So only the DR, the designated router, generate a type 2 LSA. The type 2 LSA are flooded within the multi-access network and do not go beyond the ABR. So again, this is within the area. I think we have the same issue here than that we do on a single area OSPF. Then we have the type 3 LSAs, and they describes a network address learned by a type 1 LSA. A type 3 LSA is required for every subnet. ABRs flood type 3 LSA to other areas and are regenerated by the other ABRs. So this is when we want to connect within the different areas. So if you have learned something with a layer or a type 1 LSA within your area and you want to tell the other areas about this network, you are using a type 3. And by default here we can see that the routes are not summarized. Then we have the type 4, and this is where we have the ASBRs when we have an internet connection. These are the route that generates information about that. So a type 4 LSA is generated by the originating ABR and regenerated by other ABRs. A type 4 link state ID is identified by the router ID of the ASBR. So this is where we have connection to the internet. And a type 5 is also what we use to advertise an external route, a non-OSPF route. That could be if we have connection to other types of routing protocols, we can use a type 5 to identify that and put it in as an external route. So that is the type 5. Yeah, and we can see, for instance, when we are using the show IP route to show the routing information from OSPF, we will see that we have the O in front of it to identify that this is something we'll learn from OSPF. The IA is a summary LSA that will tell us about the inter-area routes. So this is routes that I will know of in a different area than myself. And we can see also there is an external, either an external type 1 or an external type 2 that will also be identified in our routing table. Yeah. The route calculation will be seen that we will see that there are, again, the best path. We will find the best path within the intra. Of course, it will always choose the intra area because that's the fastest. That's the area that I'm within myself. And then it will be updated with the other areas after that. All routes calculate the best path or paths to external autonomous systems as well, with a E1 or an E2. We will see the distance or the cost for that routes as well. Yeah, and that was it. Thank you.